In the past, we've taken a look at how a prism can bend light through the process of refraction using Snell's law. Today what I want to show you is how a lens, through the process of refraction, can either cause light to converge at a point or to cause light to diverge away from a point. Alright, to do this, I should probably turn on some lights here. Today what I'm going to do is show you how the same refraction which we saw in a prism occurs in both a concave and a convex lens. Today I want to take that idea of refraction from a prism and apply it to both a convex and a concave lens so that you can see how and why they focus light to a point. Now a convex lens, much like a prism, has two sides which are at angles to one another. And what that means is as light passes into the lens, much like a prism, it refracts, and when it exits the lens, it again refracts. So we'll see refraction in this lens much like we would with a prism. Looking at a light ray which is traveling parallel to the principal axis when it strikes this lens, we can see that this ray will bend according to Snell's law. And so as this ray travels from air into the glass of the lens, it is going to refract, and it's actually going to bend downward or towards the normal line. Now when this ray exits the lens, it's again going to refract. But as the ray exits the lens, because it's traveling from this glass into the air, it's actually going to bend away from the normal line, which again means the ray is going to refract farther downward, causing the ray to cross the principal axis at this point. Now going back to our prism, when light enters this prism and then exits the prism, regardless of where it strikes the prism, it's always entering and exiting the prism at the same angle, and that means all the rays coming out of the prism are traveling parallel to one another. With this lens, that's not the case. The lens is curved. And so depending on where light strikes this lens, it may refract in different directions other than what it did here. Looking at this ray which strikes the lens down here, we can see this ray strikes the lens at an angle relative to the normal that is different than up here. When this ray strikes the lens here, it's going to be bent towards the normal, just like this ray was. However, in this case, that means the ray is going to be bent up. And when this ray exits the glass into the air, just like up here, it's going to bend away from the normal, except this time that means the ray is going to be bent even farther upward. So what we see is when light traveling parallel to the principal axis, whether that be up here or down here, strikes a convex lens, that light is refracted through this point right here, or forced to converge at this point. And this point is what we call the focal point. Because a convex lens forces light which is coming in parallel to the primary axis to converge on a point, we say a convex lens is convergent. Now, unlike a mirror which only has a single focal point, a lens actually has two focal points. The second focal point for a lens is actually over here. And those two focal points are both equidistant or the same distance away from the middle of the lens. And we can use this other focal point to our advantage in ray diagrams by understanding exactly what it is that light which travels through this focal point will do. If we're to look at a light ray which passes through this focal point and strikes the lens right here, this ray is going to be refracted. Just like any other ray which is traveling from air into the glass, that ray is going to refract towards the normal vector. And when that ray passes through the lens, it's going to pass from glass into air, and therefore it will refract away from the normal vector. And so this ray which strikes the lens having passed through this focal point is going to refract and travel out of the lens parallel to the primary axis. And this is true of any ray which passes through this focal point. So with a convex lens, any ray which travels into the lens parallel to the primary axis is going to pass through this far focal point, and any ray which passes through this focal point on its way to the lens is going to pass out of the lens, traveling parallel to the primary axis. Now, a concave lens also causes light to refract, but a concave lens is what we call a divergent lens, meaning it makes the light spread out. Really, it does the opposite of a convex lens. Now, a concave lens, just like a convex lens, still has two focal points. But those two focal points are reversed. So let's take a look at a ray striking a concave lens to see exactly how a concave lens works differently from a convex lens. See, when this ray strikes this concave lens, it's going to refract, just like this ray, which struck the convex lens, was refracted. But because this lens is bent in the opposite direction that this convex lens was bent, the ray is going to refract in the opposite direction. So rather than being bent down like it was here, it's going to refract upward. After passing through the lens, this ray is going to refract upward, not towards this focal point, but away from it. In fact, it's going to be traveling in a direction such that it will appear to have originated from this focal point right here. And if we were to take a look at a ray which strikes the lens down here, we'll see the same thing. The ray bends away from this focal point and behaves as though it had passed through this focal point. And much like we saw over here with the rays which struck this lens at an angle having passed through this focal point, we'll see rays which strike a concave lens at an angle headed towards this focal point are refracted away from this focal point and travel away from the lens parallel to the primary axis. So when dealing with a convex lens, it's important to remember that the light is always going to be bent towards this focal point. Now, only certain rays will actually strike this focal point based on their incident angles at which they strike the lens, but they will all be bent towards the focal point. In just the opposite manner, when dealing with a concave lens, the light will always be spread apart or pushed away from this focal point over here. And just for fun, I'm going to put a couple of these in a row. Oh, that's cool. And on that note, that's all for now.